Have you ever looked at a modern cloud architecture diagram? You know the ones I mean. Those sprawling, chaotic charts with arrows pointing in like 14 different directions.
The spaghetti charts.
Exactly, the spaghetti charts. You've got boxes for load balancers, cylinders for databases, dotted lines for VPC peering, and about 50 acronyms that I swear didn't exist last week. It feels less like an engineering schematic and more like you're trying to decipher an alien language.
It really does. Or maybe a map of the London Underground drawn by someone who's never actually been to London.
That's a perfect analogy. And it is a common feeling, I think.
Mm-hmm.
It used to be so much simpler, didn't it? You bought a server rack, you shoved it in a cold room, and you prayed the AC didn't die.
Right. Now, a single application might rely on hundreds of distinct ephemeral services that spin up and then die in, a matter of seconds. The complexity is just on another level.
And that complexity is terrifying. But here's the thing. It's not just about the confusion of looking at the chart. It's about cost, and honestly, it's about business survival. I was digging into the research for this deep dive, and this one concept kept coming up again and again. Technical debt.
Ah, yes. The ghost in the machine.
It seems like when that big gold rush to the cloud started, a lot of companies just did what they call a lift and shift.
They did. It was the path of least resistance. They took their messy, old-school server setups, which were already, frankly, inefficient, and just plonked them onto Amazon or Azure.
Which sounds convenient, right? Until the bill arrives.
Exactly. That's when the sticker shock hits. You end up paying a premium for inefficiencies you didn't even know you had. It's like moving into a brand new high-tech smart home, but bringing your old leaky coal-burning stove with you.
And it's expensive, it's probably dangerous, and it totally defeats the purpose of the move in the first place.
It absolutely does. And that's what our research shows leads to these spiraling bills and, even worse, security nightmares.
But there is a solution. And that is what we are going to unpack today. We are talking about well-architected frameworks, or WAFs. And before you, our listener, tune out thinking framework sounds like a boring corporate rulebook, I really want you to reframe this. Think of this as the GPS for the cloud. Or maybe an architectural constitution.
That is a great way to put it. It really isn't a rule book. It's the collective wisdom of millions, literally millions of workloads, all distilled into a guide on how not to blow up your infrastructure or your bank account.
So we aren't just talking about which buttons to click in AWS or Azure today.
No. We are talking about the philosophy of building systems that actually survive the chaos of the internet. We aren't just talking about technology. We are, at the end of the day, talking about survival.
But first, I have a very, very important message for everyone listening. Welcome to InfoSec Bytes, your go-to podcast for bite-sized insights on information security, AI, cloud, quantum, and cybersecurity incident root cause analysis. With over 100 episodes, we've got you covered on the latest trends and tips. This year, we will focus more on cloud computing along with other topics, so stay tuned. Please like, subscribe, and share to join the conversation on various platforms like Spotify, Apple Podcasts, YouTube, and Amazon Music, and stay secure. Okay, with that out of the way, let's get into the meat of this. We are decoding the massive frameworks that basically keep the internet running.
It's good to be here. And, you hit on something absolutely crucial right at the start. The shift from on-premise to cloud isn't just a change of location. It is a fundamental change of mindset, a philosophical shift. In the old days, architecture was, it was static.
Right. You had to be a fortune teller. You had to sit down and guess, okay, how much traffic will we have in 3 years? Then you buy that much hardware, and you were just stuck with it.
And you were almost always wrong. It was a fool's errand. You either overbought and wasted millions of dollars on empty metal boxes just sitting there collecting dust.
Or you underbought.
Or you underbought and your entire website crashed on Black Friday, which is, a career-limiting move.
The worst of both worlds, really.
Exactly. Cloud architecture, on the other hand, is evolutionary. You have to design for change from day one. But, and this is the core philosophy the research really highlights, well-architected frameworks are fundamentally about managing trade-offs. There is simply no such thing as a perfect system.
I feel like my boss needs to hear that on a loop. I want it fast, cheap, and completely unhackable.
We all want the unicorn, don't we? But in the real world of engineering, you cannot have infinite speed, zero cost, and perfect security all at the same time. It's just not possible. The WFs, what they do is they force you to be honest about those choices.
Can you give us a really concrete example of that kind of trade-off?
Sure. Let's look at reliability. It's a classic one. If you want what we call 5 nines of availability, that means you are almost never offline, maybe just a few minutes per year at most. You need massive, massive redundancy.
So backup servers, copies of data everywhere.
Right. You need backup servers, data replicated across different geographic regions, maybe even using different cloud providers as a failsafe. All of that increases complexity and inevitably it increases your cost, sometimes dramatically.
So the well-architected framework helps you sit down and decide, is my app actually critical enough to justify doubling my monthly bill for that extra 0.001% of uptime?
That's precisely the conversation it forces you to have. If
Right.
you are running a personal blog, maybe being down for an hour isn't a disaster.
Yeah.
But if you are running a hospital's patient database, it absolutely is. The framework helps you make an informed decision rather than, an accidental one.
And the way all the major providers, AWS, Azure, Google Cloud, IBM, do this is through something they call pillars.
Pillars, yes, I like that image too. They are literally holding up the roof of your cloud house.
A shared structural archetype, I think the research called it.
It is. They all categorize their non-functional requirements, the ELITs like reliability, scalability, into these pillars. And before we dive into the specific pillars, we have to mention the shared responsibility model. This comes up constantly in the research because it is where most people get burned badly.
This is the who locks the door question, right?
It is exactly that. The cloud provider, say Amazon, secures the cloud. That means the concrete, the fences around the data center, the physical hardware, the electricity, the core networking, they handle that. But you, the user, you must secure what is in the cloud.
So if I leave my digital front door wide open, like if I leave a database password as admin123, Amazon isn't going to jump in and change it for me.
They can't. They don't have the keys to your house. That is entirely on you. The analogy I like is if you build a house with no locks in a very safe neighborhood and you get robbed, you can't blame the neighborhood security guard.
That makes perfect sense. Okay, let's unpack these pillars. The research shows that while the names can vary a little bit between Amazon, Google, and Microsoft, there are 5, sometimes 6 standard ones. Let's start with the one that sounds the most corporate, but might be the most critical: operational excellence.
This is so often the most overlooked pillar. People hear operations and they think it's just about keeping the lights on.
Yeah, the boring stuff.
But in a well-architected sense, it is about operations as code.
Operations as code. That sounds great, but let's break that down. What does that actually look like in practice versus, the old way?
The old way was the run book. That
Yeah.
dusty 3-ring binder sitting on a desk somewhere that says, if the server crashes, type this command. If that doesn't work, call Bob.
And if Bob is on vacation, or it's 3 in the morning.
Then you are down until Bob gets back from his cruise. That is operational fragility. It's a business risk. Operations as code means we move completely away from manual runbooks. You write code that automates that response. If a server fails, a piece of code detects it, terminates the bad server, and spins up a new, healthy one instantly.
So you are essentially automating yourself out of those horrible 3 a.m. wake-up calls.
That is the ultimate goal. In this world, human intervention is a bug, not a feature. And this ties into a really important cultural aspect mentioned in the research called the blameless postmortem. This is heavily, heavily influenced by Google's site reliability engineering, or SRE, culture.
I love this concept. It's so counterintuitive to the traditional corporate culture of, finding someone to blame.
It is. When something breaks, the gut instinct in many places is to find a throat to choke. Who pushed the bad code? Who's getting fired? But the well-architected approach says, no, that's the wrong question. If a human made a mistake, it's because the system allowed them to make that mistake.
So you don't fire the engineer, you fix the guardrail that let the engineer crash the car in the first place.
Exactly. Failure is viewed as a precious, non-renewable resource. It's an opportunity to learn and make the system stronger, not to punish an individual.
It reminds me of a question I want to ask our listener right now. How often does your team fear deployment day? Seriously, if you are sweating every time you push a button, or if Friday deployments are banned in your company because everyone is terrified of ruining the weekend, you probably aren't hitting this pillar of operational excellence.
That is a fantastic litmus test.
It's about removing that fear through consistency and automation, isn't it?
Absolutely. Predictability is the key. You want boring deployments. Boring is good. Boring means it's working.
Moving on to the next pillar, and this is the heavy hitter, security. The research mentions a massive shift here from perimeter security to identity security.
Yes. This is probably the biggest change in the last 20 years of security. In the old days, you had a firewall, a castle wall. Everything inside the wall was trusted. Everything outside was untrusted. It was a crunchy shell protecting a soft, chewy center.
But in the cloud, there is no wall. There's no perimeter.
Right. There's no single entry point. Your employees are accessing data from coffee shops, from their phones, from different countries. Your servers are constantly talking to third-party APIs all over the world. So the firewall is no longer the main defense. Identity is.
So proving who you are is more important than where you are sitting.
Correct. It's all about authentication and authorization. This leads directly to the concept of zero trust.
Which sounds incredibly cynical. I trust no one.
It is cynical, but it's also necessary in today's world. The motto is never trust, always verify. Just because a request comes from inside the corporate network doesn't mean it should automatically have access to the payroll database. You verify every single request every time, regardless of its origin.
And the research also used the phrase shift left regarding security. I assume that doesn't mean moving your desk to the left side of the office.
No, not quite. Imagine a timeline of software development, moving from left to right. It starts with design, then goes to coding, then testing, and finally deployment. Shift left means moving security checks as early as possible in that timeline.
So you don't build the entire application and then hire a security person to come in and bolt a lock on it at the very end.
Exactly. Because at that point, it's too late. That is how you get vulnerabilities. You integrate security while you are writing the code. You scan for issues before the code ever leaves the developer's laptop. You make security part of everyone's job, not just the security team's job.
That must save so much time and money, too. Fixing a security flaw in the design phase is basically free. Fixing a hack in production can cost millions.
Precisely. And we can't forget the basics of data protection here. The research is very clear on this. Encryption both at rest and in transit. Whether your data is just sitting on a hard drive somewhere or flying across fiber optic cables, it needs to be unreadable to anyone who might intercept it. It's non-negotiable.
Okay, pillar number 3, reliability. This is where the rubber meets the road. If the site is down, nobody is making money.
Yeah.
But the expert view here is really interesting. It starts with a quote from Amazon's CTO, Werner Vogels, "Everything fails."
Everything fails all the time. The mindset shift here is profound. In traditional IT, you spent millions trying to prevent failure. You bought the most expensive gold-plated hardware, hoping it would never, ever break.
But in the cloud, you just assume it will break.
You design for failure. You embrace it. You don't design to prevent it because you can't. You design to recover from it swiftly and automatically.
Is this where that chaos engineering stuff comes in?
Yes, this is where it gets really fun. The research mentions Netflix as a pioneer here with their tool called Chaos Monkey. It's a piece of software that intentionally breaks things in their own live production environment to test their resilience.
That sounds insane.
Yeah.
I mean, breaking your own stuff on purpose while customers are watching.
It sounds crazy until you understand the logic. They will randomly turn off servers, sever network connections, and introduce latency just to see if the system as a whole can handle it. The thinking is, it is much better to have your system break at 10 a.m. on a Tuesday when all your engineers are awake, caffeinated, and ready, than to have it break spontaneously at 2 a.m. on a Sunday.
That is a fair point. It's like a fire drill, but with, real fire. And this connects to the idea of self-healing, right?
Yes. We mentioned auto-scaling earlier. If traffic spikes, the system automatically adds more servers, but self-healing goes further. If a server dies, the system detects it, removes it from the pool, and replaces it with a new one. It fixes itself without any human intervention. And importantly, we change our metrics. We stop looking just at uptime is the server on, and we start looking at user-centric metrics.
Like the success rate of user requests.
Right. It doesn't matter if your server is on, if it's sending error messages to every single customer. From the business perspective, that is downtime. So we measure what the user is experiencing, not what the machine is doing.
Okay, next up, performance efficiency. This isn't just about raw speed, is it?
No, it's about efficiency. It's about doing more with less. And a big part of this pillar that the research highlights is democratizing tech.
That sounds fancy. What does it mean for the average developer out there?
It means you don't have to be a PhD in machine learning or blockchain or quantum computing to use those technologies. The cloud provider does the really hard work, the undifferentiated heavy lifting, and you just consume it as a service through an API.
So it lowers the barrier to entry for really advanced tech.
Immensely. But the key principle for this pillar is stop guessing. Don't provision for your peak load. You don't buy a stadium for a birthday party. You scale elastically.
And mechanical sympathy. I saw that term in the research. It sounds like feeling sorry for your car when you hit a pothole.
It kind of is. It comes from racing car drivers. The idea is that a driver who understands how the engine and suspension work actually drives the car better and faster. In the cloud, it means using the right tool for the job.
So don't use a hammer to turn a screw, even if you really like your hammer.
Exactly. Don't use a standard SQL database just because it's familiar if what you're really trying to do is map complex social relationships. Use a graph database, that's what it's for. Don't run a server 24/7 if you only need a piece of code to run for 3 seconds when a user uploads a photo use serverless functions like AWS Lambda or Azure Functions.
Undifferentiated heavy lifting. I love that phrase. It's like, why build your own power plant when you can just plug into the grid? Okay, the final of the standard pillars, cost optimization.
Or as the cool kids are calling it now, FinOps.
Money.
Yeah.
This is usually the part of the conversation where the finance department starts listening very carefully.
It is. But it's really important to stress, it's not just about cutting costs. It is about spending efficiently. It's about value. And you can't optimize what you can't measure. The research talks endlessly about the importance of tagging. You need to put a label, a tag, on every single resource so you know that this server belongs to the marketing department and that database belongs to engineering.
So you can actually send them a bill at the end of the month and maybe shame them for leaving a giant server running all weekend for no reason.
Accountability drives efficiency. It's amazing how quickly things get turned off when people know they're being charged for them. And you have to understand the different pricing models. You have things like spot instances, which are like spare capacity that the cloud provider sells off really cheaply.
Like a standby ticket for a flight.
That's the perfect analogy. It's super cheap, but they can kick you off with 2 minutes notice if a full-paying customer shows up. So it's great for background data processing, but it's terrible for hosting a critical database that has to be online.
And the opposite is reserved instances.
Exactly. That's where you commit to using a certain amount of compute for a year or 3, and in exchange, you get a huge discount, sometimes up to 70%.
I really liked your reflection in the notes for this section. Cost is essentially a reliability metric. Can you explain that a bit more?
Think about it this way. If you run out of budget, what happens? The CFO shuts off your project. Your system is down just as surely as if a hacker took it offline or a data center lost power. Financial resilience is a core part of operational resilience. You can bleed to death financially just as easily as you can technically.
That is a real light bulb moment for me.
Yeah.
Okay, so those are the standard pillars. But here is where it gets really interesting, the flavor wars. Every provider, AWS, Azure, Google, IBM, has their own unique spin on this. Let's start with the big dog, AWS.
AWS really sets the standard for everyone else. They have the 5 we just discussed, but their unique addition is the 6th pillar. Sustainability.
Right. Saving the planet while you compute. This feels very, very modern.
It is, and it goes right back to that efficiency pillar. If you write bloated, inefficient code, you use more CPU cycles. More CPU cycles use more electricity, which generates more carbon. It's a direct link. AWS highlights a shared responsibility model for sustainability.
So it's not all on them.
No. They optimize the data centers, the energy grid, the water usage for cooling. Your job as the user is to optimize your code to use less energy and to select regions to run your code based on their renewable energy mix.
So running my app in, say, Oregon, which has tons of hydropower, might actually be greener than running it in Virginia or another region that relies more heavily on coal.
Exactly. It's a tangible way developers can directly impact their company's carbon footprint. And AWS also introduces this concept of lenses. These are tailor overlays on top of the framework. So if you're in the gaming industry or financial services or building a SaaS product, they have specific, detailed advice for your use case.
Now, what about Microsoft Azure? How do they approach this?
Azure is fascinating because
Yeah.
they really lean into gamification. They have something called the Azure Advisor Score.
Gamification. So I can get like a high score for my server setup.
Yes, it literally gives you a percentage grade. It scans your setup and tells you you are 78% well architected. It's incredibly powerful for motivation. No engineer likes having a B grade. They want that 100%. They'll work to fix the recommendations to get their score up.
That's some clever psychology right there.
It really is. They also focus heavily on a maturity model. It's not just pass or fail. They frame it as a journey from level 1, get resilient, all the way up to level 5, future-proof agility. And because it's Microsoft, There's a huge focus on hybrid integration, making sure your cloud seamlessly talks to your on-premise Active Directory and Office 365. It's their home turf.
That feels very structured, very Microsoft. What about Google Cloud?
Google is, as you'd expect, heavily influenced by their internal SRE culture. They actually have a separate, distinct category for system design, which is interesting. But their big differentiator is the relentless focus on metrics like SLOs, service level objectives, and, my favorite, error budgets.
Error budgets. That sounds like I'm allowed to make mistakes.
You are. That's the point. Google's philosophy is that 100% reliability is not only impossible, but also undesirable. It's too expensive, and it slows down innovation to a crawl. So you set an SLO, say 99.9% uptime. That remaining 0.1% is your error budget.
So you can spend that budget on taking risks.
Precisely. If you haven't had any downtime yet this month, you can use that budget. You can push new features faster. But if you burn your budget, if you have an outage, all new development freezes. Your team has to focus entirely on stability until you earn that budget back.
That is such a healthy and rational way to look at failure. It creates a natural balance between the need for speed and the need for safety. Finally, IBM Cloud. They are often the quiet giant in the room.
IBM has carved out a very specific niche for themselves: hybrid and portable. They're the only one of the big four with a specific hybrid pillar. They focus on the reality that big banks, insurance companies, and global enterprises aren't just in the public cloud. They have mainframes, private data centers, and they often use multiple clouds.
And the research mentioned a concept called data gravity.
Yes, the concept that data is heavy. It's hard and expensive to move petabytes of data around. It takes time and costs a lot of money in egress fees. So IBM's philosophy is that applications should move to where the data is, not the other way around. They build tools to make that portability easier.
And they have a strong vertical focus, right?
A massive one, specifically on financial services. Their framework has over 600 specific controls built in just for banking regulations. They've done the compliance mapping for you.
So if you are a bank, IBM has basically done your regulatory homework for you.
To a very large extent, yes. They are designing for highly regulated industries where compliance isn't just a suggestion, it's the law.
Now let's look forward. The research gets really exciting here, talking about a massive update coming in the 2025-2026 timeframe regarding AI. This isn't just about using AI tools to write code, it's about how AI fundamentally changes the architecture itself.
This is the new frontier. We are already starting to see generative AI lenses pop up. When you are building with large language models, the old architectural questions are still there, but a new set emerges. It's no longer just, is the server up? It's, is the server telling the truth?
Right. Responsible AI. Suddenly we have to worry about things like fairness, explainability, and hallucinations.
Exactly. The architect now has to consider veracity as a core non-functional requirement. If your customer service chatbot lies to a customer and promises them a discount that doesn't actually exist, that is an architectural failure, not just a content failure. You need to build guardrails to prevent that.
And then there's agentic AI, agents that can act autonomously.
This is where we get into the realm of self-evolving systems. The research speculates, and frankly we are already seeing the early signs of this, that we are moving towards systems that use AI to architect themselves. Imagine a system that detects a performance bottleneck, realizes its database configuration is wrong for the current workload, and then rewrites its own infrastructure code to deploy a better configuration.
All without a human ever checking a dashboard.
Without a human even knowing it happened until they see the weekly performance report and notice that things just got faster.
That is both absolutely amazing and, I have to admit, slightly terrifying. It gives me some mild Skynet vibes.
Ideally, it's just incredibly efficient. But it does raise the stakes for the human element. Even with all this amazing AI, the Cloud Center of Excellence, or CCOE, becomes more vital than ever. You need humans to set the governance, the ethics, and the financial boundaries for these autonomous agents.
So we aren't losing our jobs to AI just yet.
No, but the job description is changing. It's evolving from builder to governor. We stop laying the individual bricks, and we start defining the zoning laws for the AI that builds the city.
Okay, so we've covered the philosophy, the pillars, the different provider flavors, and the future. But how do our listeners actually use this information? I mean, practically. I don't want people to just nod along and then go right back to their messy architecture.
It all starts with the Well-Architected Framework Review, or WAFFR. And I want to really stress this point. This is not an audit.
The word audit makes everyone tense up immediately. It sounds punitive.
Exactly. An audit implies you're in trouble and someone is looking for fault. A review is a conversation. It is designed to be helpful, collaborative. It's a health check for your system.
So you sit down with your team and you just go through the questions. How are we doing on encryption? Do we actually have a disaster recovery plan that we've tested?
Precisely. And you don't have to guess. There are excellent tools to help you. AWS has the well-architected tool built right into their console. Azure has Azure Advisor. These tools will automatically scan your environment and tell you, hey, you have a security port open to the entire internet here, or you're spending $1,000 a month on a database you haven't used in 6 months.
That's like a spell checker for your infrastructure.
That's a perfect analogy. And how often should we be doing this? The research suggests a review should happen every 12 to 18 months. The cloud moves so fast. An architecture that was perfect in 2024 might be obsolete or dangerously insecure by 2026 because new services and new threats have emerged.
And here's the kicker, the incentives. I saw something in the notes about free money.
In a way, yes. Providers really want you to be well-architected because well-architected customers stay longer, they scale bigger, and they complain a lot less. So someone like AWS will often offer funding like $5,000 in service credits if you work with one of their certified partners to fix any high-risk issues that are found during one of these reviews.
That is a pretty good deal. Fix your major security holes and get paid for it.
It creates a wonderful virtuous cycle. It removes the friction of, I'd love to fix this, but I just don't have the budget.
So a question for you, the listener. When was the last time you actually reviewed your architecture against these pillars? Are you just drifting along, hoping for the best? Or are you actively steering the ship? You might be leaving money, or worse, security, on the table.
And please, do not try to fix everything at once. That just leads to paralysis. Prioritize. Fix the high-risk items first. The major security holes and the big reliability risks come before you start optimizing that last 5% of cost. Stop the bleeding before you start the plastic surgery.
That's great advice.
So before we wrap up, I just want to summarize. Well-architected frameworks are the bridge. They are the thing that bridges the gap between your business goals. I want to make money, I want to launch this new feature fast, and the technical reality servers crash, hackers exist, and bills get very high. They prevent what's known as architectural rot.
Architectural rot. That sounds nasty.
It is. It's what happens when you stop paying attention to the foundations. Entropy takes over, and things slowly, quietly fall apart.
And here is a final provocative thought for everyone to mull over as we close. We talked about AI designing infrastructure. As AI begins to design and manage our infrastructure for us, will the role of the human architect shift completely? Are we moving from being the builders of the digital world to being the ethicists and the governors? If the AI builds the house, is our only job left to make sure it doesn't build a dungeon in the basement?
That is the defining question for our profession over the next decade.
Indeed it is. Well, that brings us to the end of this deep dive. Thanks for tuning in to InfoSec Bytes. Keep exploring our 100-plus episodes on information security, AI, cloud, quantum, and cybersecurity incident root cause analysis. Please like, subscribe. We're on various platforms like Spotify, Apple Podcasts, YouTube, and Amazon Music, and share to stay connected and keep your cyber defenses strong. See you in the next episode. Stay tuned.